Welcome to the notes on alternate interior angles and same side interior angles. But before we can do this set of notes, I need to back us up a little bit and remind us of everything we've done so far, on angles at least. So, when we've been learning about these angle pair relationships, which is what the whole unit's about, we've been having two categories. Category number one is the relationship. And it's about how two angles specifically are connected to each other. And then the second part is how we describe those relationships. The first thing we learned about angle pair relationships was the descriptions. So for example, we learned that the word congruent meant that they were the same. And so that was one type of description. We also learned that the word complementary meant that they add to 90. So the two angles we're talking about would add up to 90. Now the third one was the word supplementary, which meant the two angles add to 180. And so those are the three ways we can describe angle relationships. However, then there's the name of the relationship. Like, what kind of relationship is it? So far we've learned three types. We've learned straight line pairs, remember these angles are on a straight line together. So it's like if this was angle 1, like that, angle 2 would be this guy, and then that guy. Because together they make a straight line. And because they're on a straight line, the straight line pair, its description was that it was supplementary. It adds to 180. Another type of angle pair that we've learned so far is vertical angles. And remember, vertical angles were directly across from each other. So in this situation, this one here up atop and this one here down below would be considered vertical angles. As well, this one here on the left and this one here on the right would be vertical angles to each other. Now, vertical angles are always congruent. They're always the same. So if the top one is 30, the bottom one's also 30. And if this one's 100, that one's also 100. It means they're the same because they're vertical from each other. And then the third one we've learned so far is corresponding angles. With corresponding angles, you needed two parallel lines and then a transversal that crossed it. And in this situation, for example, this guy right here would be the same as this one right here. Because along the transversal, they're both in the upper right-hand corner. Okay, and the corresponding angles, their description was they were also always congruent. Always end up being the same. So now we're going to start the notes on two more relationships. So it's this relationship, the first one we're going to learn, is called alternate interior angles. So, suppose A in the diagram is 48. So A is 48. Okay. Well, use what we know about angle pair relationships to try to figure out the measure of angle B. Well, we just learned straight line pairs, and I don't know anything about that with A. I don't have a vertical angle to A. But the third one's a corresponding angle, and A corresponds to right here. So I also know this guy here is 48 degrees because it corresponds with A. And now, if I go back through my angle pair relationships, this isn't a straight line pair with B, but it is a vertical angle to B, and vertical angles are also always congruent. So that means angle B is also 48. Okay? So here's what it means to be alternate interior angles. It's when there's two parallel lines with a transversal, just like with corresponding angles, right? But for this, these angles aren't corresponding. They're on alternate sides of the transversal. Alternate means opposite. So this one's on the left and this one's on the right. And interior means inside the parallel lines. So they're both in the parallel lines. So these two are alternate interior, A and B. And also if these two right here would be alternate interior. Okay? So alternate interior angles are two angles on opposite sides of the transversal but inside the parallel lines. All right. So now we're going to prove it. For the sake of this proof, I want to make things quicker, so I want to be lazy, and I don't want to have to call this gray guy here angle ACF, because that's so much work. So instead, I'm just going to give every angle one letter, even though it's not proper. So I'm going to make this little angle be B, and this guy in here be D, and this one in here is A. And C already looks like it's in there. F looks like it's in there, but this guy is going to be E. This guy is going to be H. And this guy here is going to be the G. So I'm going to do this the lazy way, where we just put a letter in the angle instead of doing it the proper way, where you go from dot to dot to dot. So here's the proof. As you can tell, what's highlighted gray right now is angle B and angle G. So my goal at the very, very end is to prove that angle B is congruent, because if you look up here, you saw that angle B was the same as angle A. They were both 48. So I'm trying to prove that they're congruent to angle G. Because in this picture, B is alternate interior with G. So is D and F, but we're just going to prove B and G. We could prove both. It doesn't matter. Okay, so our goal is to get to here. I'm going to use a flowchart proof, which has my circles. So I'm going to do it the exact same way we did it up here. Where if I know what angle B is, I can say that angle B is congruent to angle E, this guy down here, because they're corresponding angles. So corresponding angles is my reason, because I know that corresponding angles are always congruent, the same, right? The whole world knows that, who knows math. So you can say that that's your reason, because they're corresponding angles. It means they're the same, okay? But now that I know B is the same as E, I also know E is the same as G, because those are vertical angles. So I can say that, I did not give myself room for this. I can say that E is the same as G because they're vertical angles. Sorry about how squished that got. So now, if B equals E and E equals G, I can substitute into each other and say, then I have to say that B equals G too, because if B equals E and E equals G, then B also equals G. And I know that through substitution. Because when you substitute the fact that E equals G into this one and put a G there instead, I get that B equals G. And now I've proven that alternate interior angles are the exact same. They're congruent, always. Moving on to the second one for today, we have same side angles. So it should actually be called same side interior angles, but I forgot to put that word in there when I made these notes. So it's same side interior angles because it matters that they're on the same side of the transversal, but still inside the parallel lines. So same side interior angles are two angles on the same side of the transversal inside the parallel lines. Okay? So, here's the thing about same side interior angles. Why don't we work through it to figure it out, but we'll put it right here. Same side interior angles are, you can guess, do you think they're the same, being congruent? Or do you think they're complementary, which means they add to 90? Or do you think they're supplementary, which means they add to 180? Well, let's find out. Again, because I want to be lazy, I'm going to make this B be inside here, and this A be in there, and this guy's going to be D. F's already in there. I'm going to put E in that angle, H in that angle, and G in that angle. And again, all that does is let me use one letter for the angle instead of having to write all three the long way because I want to be lazy. On the test, you have to do it the long way. Otherwise, you don't. But yeah. Okay. So here's the proof. I'm trying to prove something about angle D and angle G, so I'm going to put that at the bottom. I'm not going to put anything between them, though, because we don't know yet, we haven't figured out yet how they're connected. So here's something I do know. I'm going to start with angle D. I know that angle D is equal or congruent to its corresponding angle, which is angle H. Angle H. Because they're corresponding angles. I'm sorry, I just realized that the camera was down a little bit, so I just raised it up. I don't know if you saw that I wrote interior up here for same side interior angles, and then that this R is here so that I can plan later when we figure out what they are, we can add that in there. So, where we're at is that D equals H, or they're congruent because they're corresponding angles. And now that I'm at H, I know how H's relationship with G. H and G are on this straight line, so that makes them a straight line pair. So I can say that angle H plus angle G equal 180 because they are straight line pair. Okay? Well, if D is congruent to H, I can substitute that fact in here and put a D there instead of the H. So then, going down to what I'm trying to prove, if I put a D there, how it's connected to the G is by adding. So it's saying D plus G is 180. And we did that through substitution, because we substituted the D in for that H. And so what we've proven is that angle D and angle G also add to 180, just like G and H do, because H and D are just the same, because they're corresponding. So if they are same side interior angles, it means they are supplementary. Because remember, supplementary means to add to 180. So the description word for same side interior angles is that they are supplementary. So if I were to go back to my little chart with everything we've learned so far and add these two things in here, we have alternate interior angles, which when you have two parallel lines, give them an arrow each, make them parallel, with a transversal. Alternate interior would be this guy, and then this guy on this side here. And if you remember, when they're alternate interior, it means They're congruent. Lots of congruence. 3 things are congruent so far. And then when I add same side interior angles, which meant you had 2 parallel lines. They each get an arrow to say the parallel. This transversal, same side, means they're on the same side, but still inside those lines. Remember, same side interior angles added to 180, meaning they were supplementary.